Good morning. So we were discussing about magnetic circuits, that too series magnetic circuits. Okay. And in series magnetic circuit, we did one problem. I said it can be series composite series magnetic circuits where the material may not be iron always. It may be air, or it may be any other ferrite, any other magnetic material, and so on. So we did a single problem, and then we discussed about some important terms that are important phenomena. One is useful flux, that is in the air gap. Then was leakage flux. I said because air is also a conductor of flux, you cannot ensure that all the flux produced is confined to the core alone. Some form leakage flux. This leakage flux is not of any use for us. So because there is leakage flux, the whole of the flux that is produced may not be available as useful flux. So we brought in a coefficient or a leakage factor, coefficient or factor called lambda, which is equal to total flux by useful flux. And that will be greater than 1, obviously, because total flux comes in the numerator. It is almost around 1.15 to 1.25 in the case of electrical machines. And the third phenomena that we discussed was fringing. I said in the air gap, sometimes the flux lines may not be confined to that area itself. Some amount of fringing may occur. The longer the air gap, the larger will be the fringing. The effect of fringing is that the area of cross section to be considered in the air gap is higher. Area of cross section higher means flux density. Flux is the same. Flux density will get distributed all along that area, which means flux density B will get decreased. We discussed about saturation effect, etc. also. Now, going on to presenting the next, let's see 2 more problems in this class. Okay. I hope we get time for that. Okay. So please take down this problem. One more problem in composite series circuit. A circular iron ring, write down please, a circular iron ring has a mean circumference, of 1.5 meter. 1.5 meter. Cross-sectional area of 0.01 meter square. An air gap of width 4 mm. An air gap of width 4 mm. Width means the length of the air gap. Okay. Width 4 mm is made in the ring. Okay. Calculate the magnetizing current. Required to produce a flux of 0.8 milliweber. 0.8 milliweber in the air gap. If the ring is wound with a coil of 175 turns. Assume relative permeability of iron. As 400. And leakage coefficient as 1.25. Okay. Now I'll read the question once again. A circular iron ring has a mean circumference of 1.5 meters and a cross-sectional area of 0.01 meters square. An air gap of 4 mm width is made in the ring. Calculate the magnetizing current required to produce a flux of 0.8 milliweber in the air gap if the iron ring is wound with a coil of 175 turns. Assume relative permeability of iron as 400 and leakage coefficient as 1.25. So these are the given data. Okay, so given mean circumference is 1.5 mm, A is 0.01 meter squared. Lg is 4 mm or 4 into 10 raised to minus 3 m. Flux in the air gap, 5G. It is mentioned as the flux in the air gap is 0.8, 10 to 10 raised to minus 3 Webers. Mu r is given as 400. N is given as 175. Lambda is given as 1.25. You are asked to find out what is the magnetizing current. So if I draw the iron ring, oh God, it came very nice now. I'm getting used to drawing this. Okay, so this is your iron ring and you have a current passing through the coil here of turns 175. Now they have given you that this is 4 mm air gap. Whatever flux is there, it is 5G. Okay, now you have to do the problem in the same manner in which we did earlier. Only thing is that instead of giving the total flux, they have given you lambda and 5G. They have given you this and this, from which you have to find out the total flux. Okay, so let's deal with that first. Leakage flux or leakage factor. Leakage factor lambda is given as 1.25, which is equal to flux total by flux 5G. Therefore, flux total or flux that is to be produced here, this total flux produced by Ni will be 1.25 into 5G is 0.8 into 10 raised to minus 3. That is equal to 0.001 Weber, which is what you are going to get. This flux is 0.001 Weber. This is the only difference between the data that was given in the previous question and this data. Instead of giving you flux directly, the total flux directly that is produced by the MMF Ni is producing the flux 5. Instead of giving you flux 5 directly, they have given you the leakage factor and the flux in the air gap. Fringing, etc. have been neglected. It is not mentioned at all. So as before, what you are going to do now is you will be finding out the total reluctance. The total reluctance will be found out like this. How will you find out the total reluctance? S total is equal to S of iron plus S of air gap. Okay, S of iron path and S of air gap. That is equal to Li by mu 0 mu r into A plus Lg by mu 0 into A. Which on substitution, this I am going to give as homework. Not homework, which means you can substitute. And you will finally end up with this value. Okay, I have done this. 61592.9.6 ampere turn per Weber. As you very well know, all these digits are not of importance with the final answer, but when you calculate the value, this is what you will get. Okay. Now, finally, what are you going to do? You will say that Ni is equal to 5s. This is the formula that you are going to use. Ni is equal to 5s. N is given as 175. Flux 5 you have calculated from the leakage factor as 0.001 Weber. S is this S total, this value. The only unknown is I, which is asked. So I is equal to 5s by n, or we will substitute this as 0.001 into whatever value that you got, 615, okay, divided by 175, and you will get the final answer I as 3.5 amperes. Check whether you are getting this answer. I hope this is clear to you. So if it is a series magnetic field, series magnetic circuit that you are encountering, if the question is based on a series magnetic circuit, remember that what our aim is to finally end up or finally find out all the values that are, all the terms that are coming in this formula. Ni is equal to phi s. S of different parts, you know, add the, because it's a series circuit, you know, it is S1 resistance is also similar case. You have to add all the reluctances. You have the value of phi directly given or through leakage factor and phi g. N will be given, the only unknown will be I. Now, if at all you are given a very complicated, you know, complicated composite series circuit also, if you have now understood the concept, this is clear. See, if I have a series circuit like this, made up of different materials, okay, and different cross-sectional area, okay. Okay, in this case also I am having what all L1, A1, L2, A2, mu2 or mu R2, mu R1, L3, A3, mu R3, L4, A4, mu R4, LG, AG, mu naught only. So this is a composite series circuit. Normally for your exam, such a series circuit will not be given for solving. But even if you are given this, you know how to find out. Total reluctance will be S1 plus S2 plus S3 plus S4 plus SG. Then flux phi will be either given or found out from the leakage factor and phi g. Phi into S total is equal to Ni. If I is given, you can find out N. If N is given, you can find out I. So this is all that is there. Don't get confused with by seeing the very complicated composite network. No problem. Now, one thing that I want to mention, just go back to your question which we discussed. There's one more thing that I want to tell you. I just forgot what at that point in time. You are given that the mean circumference, all of you just listen, okay? Mean circumference of the iron ring was given as 1.5 mm and the LG was separately given as 4 mm, 1.5 meter. So what is Li? Iron ring in the mean circumference was given as 1.5. 1.5 was the total, you know, mean. You may have to decrease that 4 mm when you put it as Li is equal to 1.5 minus that 4 mm. That you have to be, you know, careful about. Okay. Did you understand? Rishikesh, did you understand, Rishikesh? What I...
Yes, ma'am.
Mansilayo? Karna iron ring in the mean circumference is 1.5 mm. They are saying that there is an air gap of it made in the ring, in that ring which is already having a circumference of 1.5 meters. So which means finally when you take this iron, the circumference or length of iron part, it is no longer 1.5, it is 1.5 minus that air gap. Okay, now is that clear? I don't know. You know, Varsha, is that clear, Varsha? Varsha?
Yes, ma'am.
Clear? So make sure,
Yes,
make sure that you do that. Okay. Make sure if when you read the question, please make sure that you are reading it correctly. Okay. Now I'm going on to parallel magnetic. fields, circuits, parallel magnetic circuits. I know I am going a little bit in a speed because I want to finish off this also, okay, since your exam is coming up. So in a parallel magnetic field, parallel magnetic circuit means the circuit will be something like this. For easiness of drawing, I am drawing a core like this. Okay. Whatever area equal or so, and I will have, say, suppose I have a coil wound like this. I am passing current I through this. Of course, flux phi will be produced here. Flux phi, which will get, bifurcated into flux phi 1 and flux phi 2. You have flux phi, which will get bifurcated into 2 or divided into 2. One will be flux phi 2 in the other, flux phi 2 and flux phi 1. Okay. So as you can see, it will be phi is equal to phi 1 plus phi 2. Let's go directly to a question. Please take down this question. Okay. A steel magnetic structure, made of a bar section, of 2 centimeter into 2 centimeter is shown. You are given. Is shown. Okay. Determine the current that the 600 turns magnetizing coil, on the left limb should carry left limb means leftmost, that vertical portion, or left arm should carry, so that a flux of 3 milliweber is produced in the right limb, which means the flux here. Sorry. The flux they are mentioning about the flux here should be 3 milliweber. So that a flux of 3 milliweber is produced in the right limb. Mu r is given as 800. Neglect leakage. Now I'll read the question once again. Check whether you have written it correctly. A steel magnetic structure made of a bar section, 2 centimeters into 2 centimeters is shown. Determine the current that the 600 turns magnetizing coil in the left limb should carry, so that a flux of 3 milliweber is produced in the right limb. Mu r is 800. Neglect leakage. Now, one thing that you have to remember is, what is this 2 centimeter into 2 centimeter? It means that this area of cross section is 2 centimeters. The vertically, I am showing only two-dimensional view. If you think about the 3-dimensional view, that area of cross section is 2 centimeter into 2 centimeter, or I can say A is equal to 4 into 10 raised to minus 4 meter square. 2 into 2 into 10 raised to minus 4. And this is in the right limb, okay? Which I can mention as phi 2. So if I draw the, just for the sake of understanding, this is phi 1, this is phi 2. So my phi 2 they have given as 3 milliweber. I have been asked to find out what should be the magnetizing current such that phi 2 is 3 milliweber. Okay, hope this much the question is clear to you. As is clear from the figure, it is not a series magnetic circuit, but it is a parallel magnetic circuit. Now I am going to draw the electrical analog or electrical equivalent of this. Electrical equivalent or electrical analog will be something like this, okay? If I draw, there will be a resistance. Then you have two parallel paths. Always remember this circuit so that you will never go wrong. Okay, this is my V, R, R1, R2. Or to put it in this in the magnetizing form, magnetic circuit form, instead of V I have mm of Ni. This is S, this is S1, this is S2. Similarly, this is I have this current as I. This is I1, this is I2, current I. Now, instead of current I, what do I have here? Flux phi. I have a flux phi 1, I have a flux phi 2. Okay, so this is what I have now. These are the magnetizing quantity or magnetic circuit quantities. Hope this is clear. So these two are the same, okay? Whatever I have drawn in the magnetic parallel, series parallel circuit, this is the same as this, okay? Which means whatever flux I have phi here, that is this flux. The reluctance of this path, S, is this. Phi 1, S1, this is phi 2, S2. Now, the dimension is also given, okay? The lengths are also given, which I have not put it here. Let me draw the dimensions also. They have said that this total length is 30 centimeter. This total length is also 30 centimeter. This length is 20 centimeters. Okay. Now, bearing this electrical circuit in mind, you know that the first thing that you can write is that what about this voltage? The voltage across this is V, voltage across this is V1, voltage across this is V2. As you know, V1 is equal to V2. The voltage drop across R1 will be the same as voltage drop across R2 because they are connected in parallel. Similarly, in our case, instead of voltage, what do we have? The MMF. The EMF, or this is EMF. Instead of that, in magnetic circuit, we have MMF. So, which means that these are the two parallel paths, okay? So we can say that the MMF in this part is the same as MMF in this part because they are parallel. So that is where we start. So we can say that there are two parallel paths because they are parallel paths. MMF in one path is the same as MMF in the other path, or we are going to do the calculation accordingly. Or MMF in the first path is the same as MMF in the second path. What is the equation for MMF? Ni is equal to phi s. Is equal to HL also. But in our case, in this problem, we are concerned only with Ni is equal to phi s. Ni we cannot take. So phi 1 S1 is equal to phi 2 S2. So let me just delete all what I have written. Have you all read it? I hope all of you have written down. Now I'm just going to continue with this problem. Okay. So, okay. It's almost time. Just give me just 5 moments. Okay. Phi1 S1 is equal to Phi2 S2, which means Phi1, I do not know what is Phi1. Phi1 into 20 into S1 is L1 by mu 0 mu r into A. S2 is L2 by mu 0 mu r into A. Everything is the same. 20 into minus 2 divided by 4 pi into 10 raised to minus 7 into 800 was mu r, 800 into area of cross section was 4 into 10 raised to minus 4 is equal to Phi2 is given. Phi2 has been given as 3 into 10 raised to minus, sorry, you can write it like that. 3 into 10 raised to minus 3 into, what is the length L2? L2 is 30 into 10 raised to minus 2 divided by 4 pi into 10 raised to minus 7 into 800 into 4 into 10 raised to minus 4. Does anyone have any doubt here? Does anyone has any doubt here? Did you all understand? I'll stop with this, but did you understand?
Yes, ma'am.
Okay. So, from which the only unknown here is Phi1, which I will get as, just check whether you're getting, Phi1 is equal to 4.5 milliweber. Now I'm going back to the other slide. See, I got Phi1 as 4.5 milliweber. I got this as 4.5 milliweber. I know this is already, this flux Phi2 is given as 3 milliweber. So the total flux phi will be Phi1 plus Phi2. Okay. So that will be, or maybe I can take this. Total flux phi is equal to Phi1 plus Phi2 is equal to 4.5 plus 3 is equal to 7.5 milliwebers. Okay, that is the total flux. Now coming back to my electrical analogy, I am concerned with this Ni. How will I find out what is the total voltage now? This is V total. Let me take this as V total. This is V. This is V1. This is V2. Now, my idea is to find out V total. V total will be V plus V1 or V plus V2 because I know V1 and V2 are the same. Similarly, in my case, if I put Ni, total Ni will be Ni, or instead of Ni, what I am taking is MMF. Okay. MMF in left limb plus MMF in middle limb or MMF in left limb plus MMF of right limb. I hope that is clear. Going back to our problem, original problem, I am concerned about this total MMF. Okay, this total MMF is equal to whatever MMF is produced here, that is our V plus either MMF of this path or MMF in this path. 1, 2. So this V plus V1 or this V plus V2. As this corresponds to this portion. This corresponds to this portion. This corresponds to this portion. I hope now it is clear. I don't know whether I have confused you. What I meant to say is the total MMF or the total voltage is equal to series voltage plus either of the two voltage drops in either of the parallel paths. Similarly, this total Ni is equal to left limb MMF plus middle limb MMF or left limb MMF plus right limb MMF. So what you do is, just give me some more time. I just want to finish off this. Okay. So 600 into I is equal to 5s plus 5.1s1 or 5s plus 5.2s2. That is equal to 5 is 7.5 milliweber 10 raised to minus 3 into s means s, the distance is 30 into 10 raised to minus 2 by 4 pi into 10 raised to minus 7 into 800 into area of cross section 4 into 10 raised to minus 4 plus, if I am considering 5.1 I got as 4.5, isn't it? 4.5 into 10 raised to minus 3 into distance L2, that is 20 into 10 raised to minus 3 by the whole thing. I will end up with this kind of a relationship, that is 600 into I equal to 7833.4. This whole thing will come to this value, or I will be 7833.4 by 600. 13.06 ampere. This is the answer that you have to get. This is the magnetizing current that is required to be produced in the left limb so that the right limb has a flux density of 0.3 milliweber. I hope this is clear. Do you require any more? I know that I have overstepped the time, 36I. Engilum, I want to make sure that you have understood. Just tell me if you have any doubts. Anyone? So this is a question where you come across a series as well as parallel branches. Which is a series branch? One more. If this is the code that we are talking about, if I had a winding here, this goes to this and this, no problem, two parallel paths, and this is the series portion. Suppose I have the winding here, it means that this is the series portion, parallel portion, parallel reluctance, parallel path 1, parallel path 2. So you have a series plus parallel. So always remember that Ni is equal to 5s is the equation that you're going to use. If it is a series circuit or if it is a series parallel circuit also. Always your attempt is to find out this reluctance and then find out this. And in the parallel path, Phi1S1, Phi2S2 will be equated, and then find out any of the unknown quantities. Finally, total Phi-S or total Ni will be equal to Phi-S plus total Ni will be equal to Phi-S plus Phi1S1 or Phi-S plus Phi2S2. As is clear from this, Phi-S, Phi1S1, Phi2S2. This is Ni. This is what we discussed today. Okay. Hope this is clear to you. I don't know whether the series test will be starting this time itself. If it starts, then all the best to all of you. That is all. Okay. Thank you for your patient listening, even after I overstepped the time.